Alright, so now we have another one. This one has a dependent voltage source. So it doesn't matter. We can still use source transformation with a dependent voltage source. And we want to take a look at it and see what we think might be the best thing to do here. You don't have to do source transformation if you don't want to. But if I do a source transformation on these two and these two, then like in the previous problem, I'll have everything in parallel. So that might be handy. So I'm going to give y'all a minute, see if you can redraw it as it would be after the source transformation. And this is supposed to say 12 ohms right there. And then we'll look at it and see if you got it right. So y'all see if you can do that. Okay, so there, the question is how simple to make a circuit. I worked this one before using two source transformations, which obviously yield a different answer. It should not have. You should get the same answer if you are going about it the right way. So probably what happened is you ended up transforming something that changed what your answer was. So like whatever the element is that you're looking at. So if I'm trying to find the current through an element, I don't want to change that to make it in parallel with something, because that changes current. Changing something that's not in parallel to something that is in parallel with something will change the current. Now it's fine for me to combine it with something it's in series with, because the current will be the same. But that's only if I'm measuring the current. And so like on the previous problem, I was measuring voltage. So I did a transformation or a simplification, a resistor simplification where I changed it, but that's because I was measuring voltage and the voltage didn't change. So I would be curious to know what transformation you did, and I can look at it and I can say, okay, well here's what the problem was. So my advice is generally you want to get it as simple as you can, but you want to be careful. And generally I avoid transforming the things that I'm supposed to be looking at. I'm not doing it here just to show that you can, as long as you're being careful. Okay, so this one would be transformed like this. Okay, now I want to be careful also when I do this. Before I transform it, I'm going to kind of drag it over to the side so we can see what direction it is. So you just kind of slide it down a little bit. So this was 6 ohms. This is 4 ohms. The current source is now going to be 72 divided by 4, which is 18 amps, pointing up because the positive is up. Now this voltage source, it says it's 3V2. V2 is the voltage across the 6 ohm resistor. Now I just kind of thought about sliding it down this way so I could see what direction it was. Now that I see what direction it is, I can make sure I put it in the right direction. This was 12 ohms. Whoops, that becomes a current source pointing down, and it becomes 3V2 over 12, which is the same as V2 over 4. Okay, so now I have 3 resistors in parallel, and I can get the equivalent resistance. There's a couple ways I can get the equivalent resistance. So I could do is the VCVS under the dependent voltage source? No. I'll tell you what that means in a second. Okay. Okay, so the VCVS, that stands for voltage controlled voltage source. So we know it's dependent, and we know what it depends on because it tells us that it's 3V2, so it's dependent on V2. So the VC just tells us it's dependent on some other voltage, but that doesn't change anything about how we work the problem. Okay, so there's two ways to get the equivalent resistance of these three resistors. One is to do it in one step, saying 1 over 1/4 plus 1/6 plus 1/12. If you have a good calculator that does nice fractions, like this one, 1 over 1/4 was it 1/4? Yeah. Plus 1/6 plus 1/12. That's not so bad. You get it pretty quickly, and it's just 2. The other way to do it is to do 2 at a time. And then that way, I know just from experience that the 6 and the 12 ohm resistor, I might not remember what they are, but that it ends up being something that's not a fraction just because it shows up a lot. So I can do the 6 ohm, and again, I am aware of the fact that I'm supposed to be measuring the voltage across the 6 ohm resistor. And so if I change the 6 ohm resistor, I want to make sure I'm not changing anything that's changing its voltage, and I'm not, because it has the same voltage across it as does the equivalent voltage in parallel. So that is okay. So that's 4 ohms for that one. And then this was V2 over 4. And then product over sum, 6 times 12 over 6 plus 12 is 72 over 18, which is 4. Now I have 2 resistors that are identical, and I know that identical resistors in parallel, the equivalent resistance is half, and so I can replace that with a 2 ohm resistor, being careful to keep in mind that, yeah, I have changed the thing that I'm looking at, but I have not changed its voltage, so I'm still okay. So this is 2 ohms, this is 18, this is V2 over 4. Okay, so now I can say my 2 current sources, I can put them together and say that's the same as 18 minus V2 over 4. And there's my 2 ohm resistor. So now I can get the voltage across the 2 ohm resistor, V equals IR, and say that that equals 18 minus V2 over 4 times 2. That's the voltage across the 2 ohm resistor, but the voltage across the 2 ohm resistor was the same as the voltage across the 4 ohm resistor and the 4 ohm resistor in parallel, which was the same as the voltage across the 4 ohm and the 6 ohm and the 12 ohm resistor in parallel, and the voltage across the 6 ohm resistor was V2. So if OneNote didn't always mess me up, I would definitely try to scroll up and show y'all. Oh, there we go. Okay, so the 6 ohm, that was V2. And then we put the 6 ohm and the 12 ohm in parallel and got a 4 ohm. And then we put the 4 ohm and the 4 ohm in parallel and got the 2 ohm. But they were all in parallel, so they all had the same voltage across them. And then, so we can say that V2 equals 18. Well, I'll go ahead and distribute the 2. 36 minus V2 over 2, or 1.5 V2 equals 36, or V2 equals 36, that's 3/2 times 2/3, or V2 equals 24 volts. Okay, questions on that one?
If it ended up with the two being in series, it would not have been the same, is what you're saying.
That's right. So, like, for instance, if I had, if I'm understanding your question correctly, and you can tell me if this is not what you were asking. So let's say my problem was like this. Okay, let's say this is my problem. So I have the 2 ohm resistor in parallel with the 2 amp current source, and I'm supposed to find the current through that 2 ohm resistor. And I see the current source and the resistor in parallel. And I say, first thing I want to do is transform it, because I hate current sources. That's just a personal thing of mine. And so I would want to transform it to a voltage source right away. But in this instance, I can't, because if I transform it, well, because it disappeared. Because if I transform it to a voltage source, then I have changed it from something that was in parallel with a current source to something that is in series, and things in, and since I'm looking for a current, currents are not the same for things in parallel, but they are the same for things in series. So if I suddenly put this in series, I'm saying it has the same current as whatever source is driving it, and it doesn't. And so that would give me a wrong answer if I did that. So I would have to solve this one in some other way. So why don't we go ahead and see? I made this up, so hopefully I can do it. Let's see. This one, probably we have that I would do, I love node voltage analysis, so I would call this V. And I would look at all the currents coming out of this node right here, and I'd make this ground, and I'd write an equation. I only need one equation here. So starting with this node that I just had, coming into it is 2 amps. Current going into it is -2. And then I have going down, I have plus V minus the voltage on the other side is 0 over 2 is the resistor. Plus, now over on the other side, the bottom node is ground. Officially, right here is another node, but I didn't really count that one because I already know the voltage there. The voltage there relative to ground has to be 3 volts, because ground is 0, this side has to be 3 volts over it. above it, so relative to ground it's 3. So I can say the other current, so we had, this is -2 this way, and I is V minus 0 over 2, and then going this way is V minus 3 over 2 equals 0. And then I'm going to multiply everything by 2 to get rid of the fractions. So -4 plus V plus V minus 3 equals 0, or 2V equals 7, or V equals 7/2 volts. Okay, the question asked for the current. So now to find the current, I equals V, the voltage on this side, minus the voltage on the other side, V minus 0 over 2 ohms, or I equals 7/2 over 2 ohms, or I equals 7/4, which is 1.75 amps. So I would not have done a source transformation on that one, and if I had, I would not have gotten the right answer. That would have given me, let's just see what it would have given me. So this is not, I kind of don't want to do it because it's not correct. I don't want anyone to think it is correct, but I'm just going to compare it. So this is a different circuit. So let's say I had a different circuit that had a 4-volt voltage source right here, and a is that a 2 ohm resistor? I used to do this when I did Zoom. I had a setup with dual monitors. It was a lot easier. I didn't have to keep dragging stuff all around. And then another 2 ohm resistor. And what did we have on this side? I already forgot. It was, shoot, 3 volts. Okay, so now when I look at these, I can figure out that if I think about this voltage source and just kind of sliding it over here, and so in that instance the minus would be at the top and the plus would be at the bottom. And so if I had 0 here, then I'd go down 3 volts here, so I'd be at -3 here, and I'd go up 4 volts here, so I'd be at +1 volt here. So I have a total of 1 volt, and then V equals IR. So 1 equals I times my total resistance, which is 4, or I equals 0.25, which is not what we got before. So that's a different current. Okay, any other questions?